Hello. This video is on chapter 2. So I want to take a moment and kind of give you a little bit of a thought process on chapter 2. As you get into chapter 2, you might feel a little overwhelmed, and I just want to tell you to take a moment and take a breath and understand that this chapter, we're going to throw a lot of terms at you. It's kind of that introductory chapter where we have to throw a ton of stuff at you, and it may not all fully click, but that's pretty much expected. It's hard to get you started on a new language without throwing a bunch of stuff at you. It's there's no real good starting spot often. So we're going to throw a bunch of terms at you, and we're going to show you where those terms are in context. And what you're going to find is it may not fully make sense. That's okay. Just keep pace with it. Try to absorb the information. And what you're going to find actually is as you're programming, that's where things are going to really start clicking. Any language you learn, at least in my experience, what's going to happen is you'll think that you understand it and it'll feel like you understand it, but you really won't understand it until you actually start to program. And so you want to get in, you want to start programming, you want to start typing out programs. And then as you're doing that, what you're going to find is you're going to come back to chapter 2 and you're going to go, oh, that really now makes sense. Oh, now I understand where that fits in. So kind of just keep that in mind as we're going through chapter 2. There's a lot of material to cover. There's a lot of slides, but really the slides actually, there's like, I don't know, 4 or 5 slides per keyword. So it should go fairly quickly as we're going through it. Please feel free if my pace is too fast to make sure you rewind if you're taking notes. And that's the nice thing about videos compared to face-to-face lectures. So let's get in and get started. Chapter 2, we're going to talk quite a bit about just some beginning structure to programming. Again, here we go. We've got the sample C++ program. So one of the first things to see about this little sample C++ program that they're showing you here is this first bit is a comment. Get used to comments. When you're sending in programs, and also really when you're developing code in the industry, comments are an important piece of programming. We want to see code that's pretty self-explanatory, but it's unfortunate that it's just not possible all the time. So we need to have what's known as code comments, and that's what we're seeing here. Now this preprocessor directive, which is the next line, we'll talk a little bit more about these as we get more into it, but that's what this pound sign is telling us. And then we're going to tell it to use a namespace. And in fact, this is telling us that we want to use the namespace standard. Now we're going to tell it that we want to make a function, main. We're going to get very comfortable using main. Main is one of the very first and most often the main function that we're going to develop. And in that block of code is where we're going to develop our code. Now, most languages, well, pretty much all languages, will have special characters. C++ is no different. We've got a list of special characters here. I'm not going to go through all of them. We just talked about that double slash, which is the beginning of comment. The pound is that beginning of the preprocessor directive. Those are definitely some of the most important ones. And then the semicolon. By the way, the semicolon is going to become the bane of your life because you're going to, for the first, forever of your programming career, for those languages that require semicolons. I don't know. I guess at this point in my career, when I get that error, my compile error, I've gotten good at reading those errors and going, oh, I missed a semicolon, and I know right where to go and put it. But I still miss semicolons. It just happens. That's just part of development. And in fact, I think it's why a lot of languages are now getting away from semicolons because it's just they're such a pain. But it is part of C++ and other languages, and so semicolon is it is, and it tells the compiler the end of a programmatic statement. So the cout is usually the first item that or the object that most students use, most students learn, and it is console out. It stands for console out, and it displays output to the computer screen. You use the stream insert operator, which is this greater than sign, to pipe what you want to the cout. So here we go. We have cout, and we're piping this programming is fun. And in fact, we can kind of bring this over here, and programming is fun, right? That's what we have there. So we're going to come here. Programming is fun. In fact, we're going to go ahead and run that. Down here, we're going to see it go. Programming is fun. There we go. Pretty neat. So that's what the cout does. And with the cout, you can use this operator, and this is known as an operator. It's one of the many operators that you will learn through your languages, through your career of languages. You can combine these together. So this will say hello there. So let's take a look at that real quick. Hello. Now, this is going to look funny because we didn't add any spaces. So we probably should have done this. And the reason why I did that is to show you can keep building on that statement. You can keep piping all this stuff into the cout. There you go. You can also do it with multiple statements, each line. Remember, semicolon on each end. More examples of using cout. And as you can see, spaces get to be a little bit funny. You gotta get used to where to put spaces. You could have put programming is with no space here, but put the space down here. It doesn't really matter in programming. I will tell you, when you get into the industry, people often like the space up here because it's more readable. Just kind of makes sense. Now, with that, you may want to say, "Hey, let's put a line break in our text." Well, the NL, and this is an L, not a 1, a manipulator allows us to do that. So we can put end L in our code. So instead of that space here, let's put ENDL. So here's what we had before. And now we have a line break. And that's what the ENDL does. So we're going to talk a little bit more. The slides go through a little bit more about the ENDL. Again, it's pretty straightforward. I'm not going to spend too much time on it. Again, we really want you to understand that this is a lowercase l and not a 1, because and the reason why we do these kind of things, we take the time to do this, is because this is going to catch you at some point. Maybe not this thing, but some silly little thing. And please know that you will, more times than you want to count, just find that the silliest little thing is what's going to make your code not compile. And I will tell you, the more tired you are, the longer it's going to take you to find the silly little thing. So there are times where I tell people, listen, if you aren't finding your error, check yourself. Are you tired? It might be time to go to bed and try again in the morning. I have gone to bed and woke up, and then literally 10 seconds in, I'm like, oh, really? That's what I couldn't find? So kind of keep that in mind. Being tired does provide quite a bit of problems when it comes to finding debug issues. All right, so in this next slide, we're showing that there's another way, which is called an escape sequence. And the escape sequence, the reason why we call it an escape sequence is this slash. Whenever you see a slash, you're seeing an escape sequence. Well, this is a specific escape sequence known as a new line escape sequence. And the difference between the two is just the way you're using it. So it does the same thing, inline versus the inline escape sequence. Now, the inline escape sequence, as you can see here, is piped in as its own little thing with no double quotes, where the inline is a slash n that's kind of put in with the text inside the double quotes. So the difference here is, again, I'm not going to have this little there, or that inline there. So instead, I'm going to put the slash n here. That's that escape sequence. And this is what's going to create the line break this time. So let's run that. See, there it is. But it's in that double quotes. Make sure you understand that. And there's good reasons to have both ways. This is sometimes a little easier to use when you're programming, let's say, maybe with data in a database, or maybe you've got form inputs. Who knows? Maybe repeatable data, this works better, or sometimes in repeatable data, this works better. There's reasons to have the multiple versions, or the multiple ways to skin a cat kind of thought process. So this is the include directive. The include directive inserts the contents of another file into the program. So by doing this includes, we are actually behind the scenes loading a whole file into our current file. This preprocessor directive, so understand this is a preprocessor. It's something that happens before the processor gets going. It's not part of the C++ language. It is the include lines not seen by the compiler. This happens all before the compiler spins up. So do not place a semicolon at the end of the include line. You do not need, in fact, you cannot put a semicolon because the preprocessor will try to read the semicolon. So we already are using a preprocessor with the include. We've already got that here with the include. I got an alarm going on. Sorry about that. So we've got the include statement here. And this IO stream is a file that C++ knows, and it's what allows us to use the cout. And so this include is loading all of IOStream into this file for us. And is what actually allows us to do the cout. Variables and literals. So pretty much everything is, for the most part, everything is either a variable or a literal. So a variable is a storage location in memory. It has a name, it has a type, data that it can hold, and must be defined before it can be used. So we have an int. This stands for integer, and this is the name of the variable. So the name of the variable is item, and it is of type int or integer. And here we can see we're declaring a variable. This is a variable definition. It's the name of the variable is number, and it's of type int or integer. Literals are just that. They're literal. We're being literal. We are saying something literally. There is nothing more. So variable can be relatively anything, right? Where literal is we're being literal. We're telling you what it is. So like in this, this is a string literal. We're telling you it's hello there. In fact, literals can't be changed. They're actually defined as constants, and so they are something that cannot be changed. 12, you can't change it. It's an integer literal. It is what it is, and so therefore that's why it's known as a literal. So we can take literals and put them into variables, and in this case, right up here, you can see we're declaring the variable apples of type integer. And now we're taking the literal 20 and we are storing it into the variable apples. So what else can we do? All right, well, we got some string literals here. Plus, we're mixing it with a variable to put it out to the string. So here we got the apples that we've declared as a variable. We're putting that literal 20 into apples, and then we're putting string literals along with a variable out to our console. Identifiers. So an identifier is a programmer-defined name for some part of a program, variable, functions. It's just a fancy way of saying, it's a programmer-defined name. So anything that's a variable or a function, we've been talking about that these are literals, that these are variables. Those are known as identifiers. And the reason why we do that is because we also have keywords, and identifiers cannot. You cannot use keywords as part of the name of the identifier. So here is this list of keywords. We're not going to go through them, but you do need to kind of know them, mainly because if all of a sudden you're trying to, let's say, create a variable name, like you can't make a variable name called constant because that's one of our keywords. And so if you start getting an error, that's why. And so why you don't necessarily need to memorize this list, it's good to have it handy, because if you run into an issue where all of a sudden you're getting an issue with a name of a variable, it might be because you're trying to use a keyword, a C++ keyword. Because if you look through this keyword, there are some keywords you might try to make as a variable name. So speaking of variable names, the variable name should represent the purpose of the variable. This is really important, and it is definitely something that I will be a stickler about in the class, and unfortunately will take points off. Please make your variable names make sense. I know the cool kids like to say int A or int X, but I can tell you as a programmer that has had to look at many developers' code after they've developed it, it makes it really hard to read the code. It makes it hard to pull it apart and understand it. So please don't do that. Make your variable names make sense. And this is a good example. If someone's ordering something, make the variable name items ordered. I know what that means. I know what's going on. And we can be 3 levels deep in the code, and I know what that means. So make sure you're making variable names make sense. The purpose of the variable is to hold and the purpose of this variable is to hold the number of items ordered. It makes sense. This, by the way, in the industry is known as self-documenting code, because you wrote the code in a way that's self-documenting. I know what this variable, I have a good understanding of what this variable is doing. So identifier rules. So this means, what can I do when it comes to naming variables? What can I do and what can I not do? The first character of an identifier must be an alpha. And by the way, if you've done other languages, you're going to find that C++ is pretty strict versus other languages. So the first character of an identifier must be an alphabetic character or an underscore. Cannot be a number. After the first character, you must use alphabetic characters, numbers, or underscores. Upper and lowercase characters are distinct. So, in other words, case does matter. So, kind of taking that into consideration, these are yes, go or no goes, right? And the first one that I get a lot of people getting so frustrated with is the period, right? You can't use periods because that also is the way we signify classes, and so you can't do it. Periods cannot contain period. Cannot use cannot begin with digits, and we cannot use special characters. All right, integer data types. Integer data types, integer variables can hold whole numbers such as 12, 7, and negative 99. So again, one of the big differences between this language and a lot of other languages, especially the higher languages, is it really does matter signed or unsigned. Remember, down in the memory of a computer, signed or unsigned, the leftmost leftmost bit, of a a numeric data type is the sign bit. So if it's a 1, it means it's positive. If it's a 0, it means it's negative. So in C++, we can actually say, no, don't do that. Actually reserve that bit for the number versus the sign. In some other languages, you don't really have a choice. So in this, we can have short ints, which means negative to positive, but we can also have unsigned, which means we can go 0 to a positive 65,000. So you can see we increase the range, but we lose the negative side. And that happens for pretty much all of the different types we have, including long int. So we have a long int, and we also have a long int, and the unsigned long int. So defining variables. Variables on the same type can be defined we can define them on the separate lines. So when we're defining ints, let's say we're defining a box, right? We want to have a length and a width. We can do it on separate lines, like we've done here, or we can do it on the same lines, int, length, and width. Variables of different types must be in different definitions. Pretty much makes sense. So integer types in programs. And here they're just kind of going through real quick to talk about that. So we've got an int here where we're checking an unsigned int. So these two are different types. That's why they have to be on different lines in long days. And now we're just assigning different values to these types, and then we're putting stuff out to the console. Pretty straightforward. Integer literals. An integer literal is an integer value that is typed into a program's code. For example, items ordered equals 15. In this code, 15 is an integer literal. And why we're saying that is because we've taken a literal and assigning it to a variable. So this variable now stands for something that was literal. Same thing what we've done here. So we can expect, we could have just taken these values and stuck them right in here and had the same results. And that's why they call that integer literals. Integer literals are stored in memory as ints by default. To store an integer constant in a long memory location, put L at the end of the number. To store an integer constant in long memory location, put LL at the end of the number. Constants that begin with 0 are base 8. Constants that begin with OX are base 16. Remember when I told you we're going to throw some things at you that kind of make sense but not fully make sense? This might be one of those pages. So let me back up here for a moment. And remember, what's going on behind the scenes is your compiler is trying to be smart, and it's trying to think about things and do things for you. And so you've created a variable here, and we're trying to shove these integers into these variables. Well, the compiler says, okay, we kind of understand what we're doing here. We're going to try to shove this into these variables, and it's going to try to do it on its own the smartest way it can. But you may want to do it a little bit smarter. So by adding these letters to the end, you're actually telling the compiler, hey, I know you want to put this number in a standard int, but I want you to put it in a long int instead. And that's why we can do that. This down here, we're just saying is with the constants that begin with 0 is we can specify, numbers. We can specify integers or chars or other things too with base 8 or base 16. Base 16 is the most common. Sometimes you'll see things with basic that people are wanting to use base 16. Speaking of the char data type, the char data type. By the way, the char data type is just a very small integer. And so it's usually only 1 byte of memory. And the char data type we can use to represent char data. Sorry, char data that so it's represented kind of behind the scenes as a number, but it stands for a char, a character. So it's a numeric value of a character from the character set that's stored in the memory. And believe it or not, we have the same thing. We have character literals. So its characters literals must be enclosed in a single quote, different than a string literal. String literals are enclosed with double quotes. Single char literals are single quotes. So character literals and programs. And here is just a short program where we've created a char variable. We're assigning some char literals and then putting them out to the console. Which brings us to the next thing. And it's also where one of the things that I start to enjoy C++ a little bit more than some of the higher languages like C# and even Java is you have actually a little bit more strength in C++. You get a little bit more power in C++. And this is kind of where you can see some of these differences. So those higher languages kind of handle strings for you without really telling you how it's being done. C++ is right in your face about it. A string is nothing more than an array of chars with a null terminator at the end. So it's a character string. A series of characters in consecutive memory location stored with the null terminator at the end, comprised of the characters between the quotes. So that's what a character string is. When I say, hey, I want to do hello with my double quotes on both sides, in memory, it's actually saying HELLO null terminator. That's how it knows, oh, I've hit the end of the character string. We also have a string class to help us do that. But again, behind the scenes, by the way, still doing all this for us. So the string class, to do this, now remember we did that pre-compiler, we're going to need that special data type support working with strings. We need to do that include strings. So let me kind of show you that. That means we need to come here. We're going to have to say include string. By doing that, we can now start to use all of these items in our code. We can define string variables in our program. We can receive values with assignment operator, and we can display them via cout. So here I have created two variables of type string. I've assigned them, and now I can utilize them. There we go. By the way, when you're doing lectures in real time and you're, I don't know, how far, we're 30 minutes into the lecture and we decide to do a quick demo like that, a lot can go wrong and you don't want to restart at 30 minutes into the lecture. So I'm glad that went well. All right. So again, here was a quick little string class that we could have also used. And again, here's the include string that we need, required for the string class, and basically what I just did. Just a different version of it. Floating point data types. So the floating point data types are float, double, long double. Long double, excuse me. They can hold real numbers such as 12.45 and negative 3.8. They're stored in a form similar to scientific notation. Remember back in math class, the E3, E4 pieces? We're going to see a version of that here in a second. All floating point numbers are signed. Okay, so once again, now we lose that ability to remove the sign. So we have single precision float, which is 4 bytes, means numbers, and that's that scientific notation we were talking about. And we have double precision, which is a double, 8 bytes, 1.7 e to the 308th. So again, pretty big on the precision. And then long double precision, which is also 8 bytes, numbers between also the same as the double precision. So floating point literals can be represented in fixed point decimal notation. So as you can see, it's basic dot notation, right? So we're saying 31.4159. We're not using any E's, right? 0.00625, or in this case, only 4 O's. Or we can use the E notation, 3.141569 e to the 1, which, by the way, is move this decimal over 1. See how that works. Or 6.25 e to the negative 5, which means move this decimal 5 places to the left, which gives us all those zeros. They are double by default, can be forced to be floats if you add the F, or long doubles if you add the L. Uppercase L, by the way. So here's a little bit of a code snippet to kind of show how that works. I will let you play with that if you'd like to. The bool data type. Bools represent a bit. Represents that they are true or false. Bool variables are stored as small integers. Actually, it's represented by a bit, not even, it's a real small integer. It literally is a bit. So false is represented by 0, true by 1. And so here, bool all done equals true is a 1. And bool finished equals false is 0. And just some little bit of code to, by the way, you can represent this a couple of ways. Hold on a second. Okay. What I want to show you is nifty little code. This is actually the code that we're looking at right here. And in this, we have the bool val equals true. Now notice we don't have true in double quotes. We don't want true to be double quotes. And what's nice about that is most compilers, in this, even my online little quick compiler, it's coloring it different because I don't have it in double quotes. If I tried putting in double quotes, it will give me an error and change the color, but we don't want to do that. So let's run this. You'll see that we're going to get that 1 and 0 output like we would expect. Boom. But because this is represented as a bit, we can also just say 1. Run this. You get the same thing because behind the scenes, it's truly being converted. False is being converted to a 0 as a bit. So that's why we're seeing that. And also, depending on your compiler, In this case, it's going to be all lowercase or all uppercase will work. Oh, nope. See, it doesn't even like that. There you go. So it wants all lowercase in this. There you go. All right. So determining the size of the data type. So the size of operator gives us the size of any data type or variable. So we have a double amount. So this is a variable amount. We're creating it as the type of double. We can say a double is stored in size of double bytes. Variable. Variable amount is stored in size of amount. So what's happening here is, let me see if I can, I'm going to code that here as well. Kind of get you to understand this one. So they're saying double amount. So we have a variable we just created. The name of the variable is amount, but the type is double. And they're saying cout a double is stored in. You just have to believe me as I type this in for a moment. Size of double let's just take a look at that code first. So first off, what you're going to need to understand here is we can, because I didn't put a semicolon here, I can break into a new line and keep piping in information. This is considered to be on the same line as this one because I don't have the semicolon out here. My semicolon's here saying that this is the end of the entire statement. Now what I'm doing is I'm doing the size of a type, not the variable, but the actual type itself. So what's the size of a double type? And if we run this, a double is stored in 8 bytes. Okay. Now, nope. Let me just pause the video and type this in real quick. Okay, with the magic of pausing the video so you don't have to wait while I type everything in. Now I've added that piece of code here that says, now we're going to actually say, give me the size of the actual variable. So now what's the size of the variable? And the variable amount is stored in 8 bytes. And the reason why we did this is, what if I came up here and just said int? Well, I'm now asking what is the size of an int, which is 4 bytes. Now, that doesn't change because, remember, amount is of type double. This is just asking for an int. So don't get that confused. That's why I want to kind of show you that. But let's go back to the way it's supposed to be, which is the double. Run that again real quick. So we're getting the size of a double, which is a type, and then size of the actual variable that we made of type double. Okay. Variable assignment and initialization. Variable assignment initialization. An assignment statement uses the equal operator to store a value in a variable, which we've been doing all along. So we kind of understand that. We wanted to make sure we talk about it because the statement assigns the value 12 to the item and variable. We can't do it backwards. Okay, so you can't say 12 equals item. It just won't work that way. Variable initialization. You can assign things as you're declaring them. So we can say int length equals 12, and you can initialize some of or all the variables. So we can say int length equals 12, comma, width equals 5, comma, and then just area. So area is going to be of type int, but has not been initialized yet. And here's an example of us doing that. Declaring variables with the auto keyword. So this is something pretty new with C++. It was introduced with 11. And that is we can use this auto keyword. This is going to allow the compiler to determine what's the best data type for that variable. And it's going to utilize especially with the when you assign something automatically to the variable, it's going to say, oh, well, this is of type int. It makes sense. So let's make it an int. And in this case, because of the decimal here, it's going to make it a double. In this case, because we use the single quotes, it's going to make this a char. And because we use the L, remember that way back then I was telling you, hey, you can be real smart and tell it to declare more memory than it would think to. That's why we use that L. If you hadn't used that L, this would make it an integer. So that's why we use that L. Scope. Now, scope we've been using all along also, but again, this is why I said this is where we're throwing terms at you so you at least at some point know how to use the terms. And as you're coding, things will start to snap together. So the scope of a variable is the part of the program which the variable can be accessed. A variable cannot be used before it is defined. Well, that makes sense. You can't declare a variable down here but have tried to use it way up here because the computer doesn't know about it yet. The program doesn't know about it yet. So that's why you have to declare the variable before you try to use it. Oh, I know. Some of you JavaScript people are going, well, we can do it in JavaScript. Yes, but there's a process that's going on behind the scenes called hoisting to let you do that. Arithmetic operators. Yep, C++ has pretty standard arithmetic operators and has unary, binary, and ternary operators. So one operand, we can do two operands. So we have 13 minus 7. And the ternary we can do where we can basically have an evaluation occur here and then true or false be given back, right? This may not make total sense to you right now if you haven't used this in other languages. That's okay. We'll get there. Just understand that this expression 1 will be determined either to be true or false. And if it's true, then this expression 2 will be evaluated. If it's false, expression 3 will be evaluated. We have the typical binary arithmetic operators, including modulus, which we will use modulus. And so here is a quick little program to go over some of the arithmetic operators. A close look at the divide operator. It's pretty straightforward. I'm not going to get too much into the weeds on this one. I want to make sure I get a little more into a close look at the modulus operator. For those that have never used modulus, it basically is telling you what the remainder is going to be. So this is taking 13, dividing it by 5, which is 2, right? Because it goes into 13 two times, but it leaves, or it has a remainder of 3 left over. So that's why it displays 3. So, you cannot do 5.0. It has to be from an integer. And one of the big reasons we use this is for random numbers between certain numbers. Like, hey, I want it between 10 and 30. We can use modulus. Also, dice like to use modulus. There's a lot of good reasons to use modulus. This is actually a pretty common operator to use. All right, comments. So again, we talked a little bit about this before at the very beginning. We need code comments in our code so we can describe why the use of variables, explain complex sections of code. They're ignored completely by the compiler. In fact, they are stripped out by the compiler when it compiles your code. And it helps to document parts of your code. So we have the single it always begins with, so single line comments always begin with the slash slash. Now you can do it in this case where we've got code out to the left, and then we decide to make a comment about this particular line by at some point putting the slash slash and then putting the comment, about this code line here. So this length in inches, width in inches, calculated area. That's great. And I don't prefer one over the other. And this is above it. So here, let's go back to our little bit of code line we had going here. We can do either way. We can say, and we would hope that our comments would be a little bit more meaningful. But again, we're using a demo kind of piece of code that doesn't have a whole lot of value. So it's hard to make meaningful comments about it. But this is just to show that we can put it out to the right. Can't put it out to the left, because whatever is to the right of these slash slash will be ignored. So again, if we try to put our comments out to the left of the line, it will ignore the entire line. So it has to be out to the right. So it's going to read this double amount so we can make the variable, and then from here on out of the line, it's going to ignore. Or we can put it above the line. Either way. And I don't prefer one over the other. What I will say is I find that people that use it out here want to try to somehow, do this justification thing. That seems a little weird to me, but again, that's a preference thing. As long as you're commenting your code, I am okay with you. And that is an important piece. You need to be commenting your code when you're turning your code in. More comments, the better. I need to know what you're thinking when you're turning in your code. Multi-line comments begin with a slash star and end with a star slash. Slash star, star slash. This is a code block, and it is a multi-line comment. So we can do the same thing. We can say, all they did up here was add more stars to make it fancier looking. I have seen people do, because, you want your stuff to look kind of cool, right? So I've seen that. It doesn't matter as long as it starts with a slash star and ends with a star slash. Named constants. It's important to have named constants. One of the tenets of good code design is to make your code as read-only as possible. The less that variables can be changed, the better your code is, right? Because believe it or not, the more your code can be changed, the more variables that can be changed actually is where the more errors that can happen in your code. So I know that sounds weird. That probably sounds like we're going backwards. Like, well, no, you want your program to be able to have variables that change. Well, yes, but you actually want to limit that as much as possible, because you want your piece of code to do a distinct function and then be done, right? So as much as you can, like in this case, we have const double tax rate 0.0675. Make that read only by saying it's a constant. So that way someone doesn't accidentally come along and your code change, because you don't want your code internally to accidentally change that. So stop it from the very beginning by naming it as a constant, and you've solved that problem. That will never be a bug in your code. So that is how you use constants. Oftentimes, and it's pretty standard across the board, most constants, when people are naming constants, it's expected to use all caps. That right away gives the fact, if you're three layers down in your code, you see a variable name that's all caps, you pretty much know it's a constant. There we go, a little bit of a program to show what that looks like. Now let's talk a little bit about programming style. The visual organization of your source code includes your spaces, tabs, blanks, lines. It doesn't affect the program itself, the syntax, but it often makes your code more readable. When you get into the industry, oftentimes most organizations actually will have not only coding standards, but part of their coding standards will be some programming styles that they prefer. I've been part of organizations that prefer two spaces tabs over four space tabs. I've been with organizations that don't like tabs at all, that they require it be spaces and not tabs, and so forth and so on. They have different levels of code commenting. So let's take one quick moment and take a look at this little program we have here that we've been playing with, and let's add a little bit of style to this, right? So I'm going to put a line break there. Let's put a line break there, a line break there. Also, let's say this block of code shows size for type, not variable. Okay. And then we say this block of code shows size for the variable. Also, part of code style in my book is being consistent. So I didn't like that bytes was on a third line. So I brought it back up because, again, now I'm consistent here, right? I like consistency. And the same thing here. If this up here was I had used the ENDL, then I would have wanted to use the ENDL down here too. So I try to keep things consistent, but see how the line breaks in the right spots make it a little bit more readable. And that's what I wanted to do. Is I wanted to show some nice stylizing on my sheet. Now, does that change?
From MLT100287.
Thank you. Does that change my actual program? No. If I run this, it doesn't, but it sure does look a lot neater and readable. And I've added some code comments so that way whoever comes along after me can see, oh, okay, this guy's the one that wrote this program. If I need any questions, I can ask him. Oh, but I don't even need to because, look, he's actually told me what he's trying to do here. Great. So there you go. That's some code styling. So that is chapter 2. Again, I know we're almost an hour in. I threw a lot at you. Don't become overwhelmed. You're going to have some questions. Feel free to shoot me some emails. If I get questions coming in, I will make sure to post them to the class so that way everyone can see the same questions coming in, answer them, as well as give any feedback. And if you've got questions about the homework specifically, feel free to shoot me emails on that as well. I definitely want to help out with that. And then the next video will cover the next chapter. I will have some videos helping out with this week as well coming up. So stay tuned. Thanks.